innovation and growth in the economics of information. Since the first reports of the Club Rome, we have been aware of the limits to growth. These limits are ultimately founded on the finite size of the planet Earth and the principles of thermodynamics. Certainly, we can think of a future in which humanity uses resources from other planets, but in the short and medium term, it seems reasonable to assume the limits of our planet. And already the first law of thermodynamics lead us to the conservation of energy and force us to consider the limitations of energy sources based on the own resource of the planet. Moreover, we know from the second law of thermodynamics that a closed system cannot increase its complexity, information content, and ultimately develop. And this development is only possible in an open system through interaction with the environment. Indeed, the planet Earth is not a closed system, but receives energy from the sun, and precisely such energy accumulated in vegetation by the chlorophyll function allow us to feed either directly or through consumption of animals that ultimately, through the food chain, receive organic material from plants. But not only that, but the organic material of fertile origins has given rise to fossil fuels such as oil. It is important to remember it today, when we have learned to directly use solar energy, not only energy from solar panels, but also oil comes ultimately from the sun, and also, of course, the wind energy. Difference of temperature from the house from the sun cause the winds that drive wind turbines. Certainly, terrestrial nuclear energy does not come from the sun, but we know the serious problems caused by nuclear fission energy that powers the current nuclear power plants, both the problem of waste and the danger of radioactive leaks, especially in case of accidents, as have tragically shown disasters of Chernobyl and Fukushima. And although nuclear fusion will not have the same problems, it does not seem prudent to rely on its availability in the short term. The truth is that for thousands of years, mankind has thrived consuming home solar energy at a rate that allowed its renewal through the energy input by the sun. By the rapid growth in energy consumption in the last 2 centuries has overflowed this renewable capacity and has had to rely on fossil energy sources that took thousands of years to accumulate. If we add the frenzied consumption of other natural resources, such as various minerals needed to manufacture our technological artifacts, and global warming caused by the greenhouse effect induced by the emission of carbon dioxide and other gases into the atmosphere, we will find us with the inescapable reality of ecological limits which we cannot exceed in the consumption of energy and other natural resources. In this context, and undertook to bear that, in fact, we have already exceeded the limits that will be sustainable, not only to limit growth, but to proceed to where decrease is advocated. Now, If as such a decrease can be effectively essential, it must be emphasized that it is strictly the consumption of energy and other natural resources which shall decrease. It is in this framework that highlights the relevance of the economics of information. For not being able to grow in energy and matter, to grow in production and consumption and information is the only resort. Certainly, the information is inextricably linked to matter and energy. There is not information without a material and energy support, but there is no proportionality between the consumption of energy and information, making it impossible to process large amounts of information with a reduced energy and material consumption. So, if Moore's law expresses how the computing power doubles approximately every 2 years, this is carried out in parallel with the process of miniaturization, saving materials and energy. This makes the economics of information is the only feasible way to sustainable development. However, the economics of information works differently to an economy based on growth of consumption and production of matter and energy. In this, the development of production was essentially a quantitative increase in the number of produced material objects, requiring what in classical economics was called enlarged capital circulation, M apostrophe, C apostrophe, M double apostrophe, C double apostrophe, and more. The commodities C produced were to be sold by a quantity M apostrophe of money greater than money and used for their production, and the reinvestment of all of part of the surplus, if which allows to expand production and to obtain a quantity C apostrophe superior of commodities. That is to say, without a monetary investment which were external to the same production, it is not possible to develop this. This makes the leading role in this production development rest with the authors of that investment, that is to say, on investors, the owners of capital invested. Even if private ownership of the means of production were annulled, as in the last century occurs in a number of countries in Eastern Europe, the leading role will continue relapsing outside the sphere of direct production, in which case the bureaucrats that control this production from outside. This does not nullify, of course, the economic role of workers, but reduce this role to repeat the cycle of production, excluding it from its development. Instead, the typical qualitative development of the economics of information is built on innovation within the work itself, without it being indispensable to obtain additional external financial investment, whose measuring is basically an increase in information, which can gradually increase without a corresponding increase in energy, which can be described by the I apostrophe E I double apostrophe scam. Also, in relation to human activity, we can describe the process by C, W, C apostrophe, W, C double apostrophe scam, while a constant amount of innovative work can lead to a progressive increase in the value of product use. Note that this scheme, although it can be applied to the commercial translation of the economics of information, also retain their validity outside the market, as does the English term commodities. Naturally, the second law of thermodynamics continues to work in the economics of information, and therefore this development continues to require interaction with the environment. But this interaction is mainly flow of information, although this, as we have said, requires an energy carrier. The flow of information necessary to fuel development may consist of training of workers on of scientific and technological cooperation. Of note, in fact, that while the development is based on innovation at work, training workers with creative and innovative capacity plays a central role. Education happens to play an essential role as an investment for development, but this investment is measured primarily at the level acquired by workers rather than in monetary terms, but of course also requires adequate funding of the education system, but nothing more than to provide for the matter energy needs of teachers and for students. Note that this is precisely one of the main objectives of the so-called Bologna process in Europe, but it must be emphasized that it is not to directly educate for the market with a short-term approach, but to educate for innovation, which is the approach that will allow a qualitative development in the medium and long term. Moreover, innovation requires a technological and scientific support, which make scientific and technological research have a central role in this development. Both higher education and work in the economics of information should be closely linked to this research. And in relation to research, remember once again that the development thrives in open systems and withers in closed systems. The free flow of scientific and technological information powers the development of research and innovation that ultimately feeds the development in the economics of information. And to the contrary, all the create obstacles to this free flow is also an obstacle to such development. In this sense, we must rethink the role played by the patent system and the so-called intellectual property. The problem, of course, is that this system was intended to control monetary flows that were central to the economy, which we might call matter energy, but only have a secondary role in the development of the economics of information. All this, naturally, affects the consideration of who are primarily entrepreneurs in the economics of information. Note that although the term enterprising has been semantically linked to the painstaking or work, entrepreneur has been only used to describe those who invest their money in business ventures, that is to say, the task for the businessman. This might make sense in an economy in which workers perform repetitive activities only, merely following the instructions of businessmen, who often came determined by the same machinery, unically designed to perform the same task over and over again. In this system, technological innovation, which was only possible through the acquisition of new machinery, which was the responsibility of the owners of such means of production, which started thus technological development and increasing of production through reinvestment of part of the surplus. But precisely this attribution of enterprising function to those owners, exclusively or primarily, is not appropriate in the context of the economics of information. While development of the economics of information relies heavily on innovation at work, entrepreneurship essentially corresponds to the workers themselves, which cannot be reduced to perform repetitive activities, but must carry out a creative activity. Naturally, the business owner can also start in innovation, but not limited to the monetary investment, but to the extent that conducts research or innovation, that is, to the extent he is acting as a worker. We speak, of course, about economics of information as a theoretical model. In many cases, companies straddle the old and the new economy and share features of the system that gives prominence to money and the system that gives prominence to work. But when we speak of the economics of information, we must be clear what is the trend linked to its development and its implications for the organization of production and even as to the general organization of the economic system. And this implication suggests that all workers must pass to play a leading role in the development of the company and therefore of the society.